Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching the most exciting series, Zero to Hero series actually, on Raspberry Pi Pico, and we are learning about MicroPython. Alright guys, so let's get started. So we are on lesson number 15. In this lesson, I am going to show you how to control a servo motor. In the previous lesson, I showed you how to control two different DC motors. But in this lesson, you will be connecting a servo motor. So let's take a look at our circuit drawing and you may follow along with me. Alright, so this is the drawing guys. It's pretty straightforward. You are going to use a potentiometer, the one which you used in lesson number I think 2 or 3 to control the LED brightness. The same potentiometer you can use it. Potentiometer is also called as a variable resistor, or you can call it as a pot. Okay, and you may use SG90 servo motor or any other servo motor which can sustain up to 6 volt, 6 maximum 6 volt, so that's the capacity of the power. Without giving an external battery power to the servo, we can drive within the code within Pico. So let's take a look at the circuit drawing guys. So basically you need to connect the PWM pin of servo motor to GPIO 0 pin of Pico. Okay, so let's take a look at our architecture diagram. Now you might be wondering, why am I showing this architectural pin diagram again and again in every lesson? Because for the beginners, for first timers, it's very easy to get confused and do a lot of mistakes on the pin configuration. If you use the wrong pin, you will burn out your Pico. It's not only related to Pico, even you use Arduino or Raspberry Pi single board computer or Jetson Nano or any of the Arduino series or any microcontroller in the world. If you hook up the pin in a wrong way and a wrong power, your board is out. It's not going to work anymore. So that's why it's very important to understand the pin configurations before you start building your project. So according to this project, so we have hooked up our PWM pin of servo motor to GPIO 0 pin. So which is the 0 pin? 0 pin is your pin number 1. Physical pin number 1 is the GPIO pin as per this drawing, right? If you look at the circuit, that is how we hooked up our servo. If you look at the yellow wire of the servo motor is connected to the first pin, the pin number 1, which is GPIO 0 of Pico. Alright, now let's look at the rest of the pins. Now we need to connect the VCC pin, that is the power pin, to 3.3 volt of Pico. Okay, and then connect the ground pin with the ground pin as per the architecture. Accordingly, you need to refer to the architecture again. There are 8 ground pins in Pico, so you can use any of the ground pins. Alright, and the 3.3 volt pin is basically pin number 36. If you look at the right side grid, the physical pin 36 is actually 3.3 volt, and there are two other 39 and 40 as well. You may use that as well. It's just 3.3 volt, but for this exercise we are taking the power from the USB port of the computer, so no need to worry. In case you want to operate through the battery, use this particular pin. All right, so let's go back to the circuit again, and the potentiometer, you need to connect to terminal 1 with the ground. Okay, and connect the output pin of the Pico to the GP28, the general purpose input output GPIO pin 28, and then connect the terminal 2 of the potentiometer to 3.3 volt again. So that's the advantage of using the breadboard, right? You can hook it up pretty much easily. So once you are ready with this guys, we can write some very basic few lines of MicroPython code, and I will walk you through systematically how it looks. So make sure that you are ready with the circuit. Make sure the pins are matching with your architectural drawing, and also make sure that you have connected your Pico to USB port and be ready with Thorny IDE. Alright, so let's get started. So what we need to do, obviously we need to import our machine. So from machine we need to import what? We need to import pin, and we are also importing PWM, pulse width modulation, to drive your motor. So this will basically import the pin and PWM from the machine library. All right, and then what we need to do, analog, oops, no, lowercase, analog value, we are taking the analog value equals to machine.adc, analog to digital converter, and convert that into pin number 28 like this. So we need to convert the analog value which we are reading from the potentiometer and convert that into the digital signal into pin number 28. That's what we are doing. And here basically, we are actually defining an object named as analog value. Analog value is an object in Python, right? And then set the analog to digital pin 28 as an analog value. So that's as simple as that. And then the PWM, we are declaring that as PWM in uppercase to pin number, say we are declaring that in pin number 0. So you need to put two different braces. One is to declare the integer and one is to declare the pin within the PWM uppercase, and then two different brackets. So this is basically another object named PWM as set as PWM in uppercase. It's an object. Again, we are creating an object in Python at pin number 0 of Pico. All right. So our servo motor will be connected to pin Pico, the signal pin. And then we need to set the PWM frequency. PWM frequency is 50. We can modify this 50 to 75, 80, depending upon the speed you want actually. So we can do that. And then we need to bring it back into the while loop. So while loop, which will basically run continuously to check if the analog input from the potentiometer and move the servo accordingly. So what we need to do, we need to say while true. Okay, while true, enter, reading equals to analog value, analog, analog, analog value dot read underscore unsigned integer 16 like this. Okay, and then we will take the duty cycle of the PWM, that is the PWM, the duty cycle of unsigned integer 16. All right, here we need to say the reading value, the reading divided by 6. So what does that 6 means? So basically in the main command, it is basically written in the while loop, so it runs continuously, right? So that's what this code will do. In an object named reading, the analog read will value and store into the PWM signal, which is basically given to the same pin on which the servo motor will be connected. So if you look at the circuit, that is exactly what happens. And we divide the analog read by 6 because we get more value, and our required value we can get by dividing it by 6, right? That's how the unsigned integer values will work accordingly. Now let's check it up, guys. I think while true, see, these are all simple mistakes, guys. It's bound to happen. What else is left out? Anything from machine? We are importing pin, PWM, analog value. I hope there are no mistakes. I think it should work. Let's take a look. All right, let me run this code. So I'm going to run this, and name reading isn't defined. Oh, reading, READING. Okay, reading. See, can you see? It's a spelling mistake. Reading. Right, it's uploaded. Now let's try to control if it works. Oh, cool. It's working, guys. So let me share the secondary video. Alright, so I have a small pan and tilt mechanism with two different servo motors. One, I left it as it is. I didn't connect it to any. I just connected one servo motor, and this is the drawing. This structure is as per the circuit drawing. So if I rotate, can you see that? Cool. The tilt mechanism was working perfectly. We can also add a couple of more servos and try to make it as a pan and tilt mechanism. That is fantastic. Can you see that, guys? Okay, so this is working perfect. So you can imagine what you can do with this particular application. If you are able to, if you can connect another servo, take this as an homework, guys. Try to connect another servo with two different values. I'm just giving you a clue. You can take another value, create a new object, and then create different variables and try to control both the servos in different angle altogether. So for example, this particular servo is for tilt. Right now another servo, you need to make it work as a pan, like this. Try to make it, but that lesson is coming soon, very soon. All right, this is working fantastic. Alright guys, so that's it for this lesson, and if you have any doubt, if you need any clarification on the code or on the circuit, or if you want one-on-one coaching, I'll be happy to do that. Do leave a message to me, do contact me on my WhatsApp, do email me. I'll be happy to help you set up a one-on-one Zoom call with you and coach you guys. Goodbye.